What is up again, Covalence friends and calendar app enthusiasts? If you haven't seen part 1 of the series yet, I do have the playlist linked below, so go ahead and check that out. And while you're doing that, go ahead and make sure that you like that video and subscribe. But in this edition, we are going to finish up defining the remainder of our queries, and we will begin implementing authentication. So we've got some exciting stuff on the back end, and let's jump right into it. So we left off having defined some of our user queries. We had our find, which we need to, log in, and we have our create function. And I think for user accounts, that's probably all we need at the moment. So yeah, let's go ahead and start defining our events. Our event queries, that is. So we'll import our query function. We'll import our event type. And then what we're going to be doing is just, like I said, this app is going to be events for, yourself and yourself alone. We're not going to be retrieving, all events and having a giant consolidated homepage of everybody's calendars. That's kind of a almost security risk like in real life. So we are definitely not going to be doing that. So we're going to be retrieving all calendar events, but for, a specific person. So we're going to be pulling in the user ID. And, I talked about this a little bit in the first video. It's kind of a little, not annoying habit of mine, but I do like having very strong single sources of truth. So we are using numerical IDs right now. We are using the serial, data type with Postgres for our IDs. But in the event I do decide to change that in the future, if I had typed this as number manually, I'd have to go and change all of my queries individually, manually, and I hate doing manual work like that. So I'd rather write just a hair bit more code at the beginning and have everything remain fully dynamic. So if we go look back at our types too, if I change this to a string here, if I say, okay, I change my users to use, UUIDs perhaps, well, because I created that dynamic reference, here, the event type user ID property now derives string from that. And therefore, user ID here is a string. So we have that kind of cascading effect from that single source of truth. If I leave this as a number, as it rightfully is, user ID here is derived as a number, and same thing here. So, that's why I like not just defining the pure JavaScript value, but instead using these referential types whenever I can. So just kind of using TypeScript as best as I can. So we're going to select all from events. If I can spell events correctly, that is. And we're going to have that user ID in the where clause. So we are just retrieving all events for a specific user. And of course, you're not going to be able to directly query anybody's, information. We're going to be deriving that from the token. So we'll be extracting that information out. We'll have some authentication, middlewares pulling that out. So you can only ever retrieve, your individual info. And of course, we do have that accepting a generic here. We can say that this function here is going to return an array of events. It's going to return a promise that resolves with an array of event objects, rather. But we've got that. The way... I'm trying to think if there's a justification for getting one event. I'm trying to mentally visualize what I want the UI to, look like, and I've got kind of a few ideas in mind, but I don't really have anything cemented quite yet. So I think I'll go ahead and just define the query, and if we do end up using it, great. And if we don't, we can always just remove it at a later point. So now, what I'm going to be doing is we'll be utilizing this user ID in every one of these queries. And we're doing this because, well, I said this user ID property is going to be derived from your token. So we will have authentication, middlewares injecting that information into like a rec user property for Express, and that's something that you can't change. So you can put whatever ID you want into like a GET request, but if the user ID is derived from who you are, who's making the request, then if I try to, get your info, if, you're user number 1 and you made post number 1, event number 1, and I'm user number 2, if I try to get, number 1, the query I'm about to write is going to say, select all from events where ID equals 1 and user ID equals 2, because that's not something I can update myself. That token is, derived from who I am. That middleware, applies that into the request object itself, so I can't alter that. And so our database is going to be unable to, find a match where those two properties align. There's no error with a database when you're trying to select something with, not a bad where clause, but a where clause where those conditions line up. But, event 1, we only have one event with an ID of 1. And it has a user ID of 1, you. So trying to access event 1, user ID 2, there's just no overlap. So that's why it's pretty critical to include these user IDs here into the just about every query we're going to be writing for the events, series of queries. So let's go ahead and I'm just going to copy this in. And we can actually more or less derive like the entirety of this line, and then we'll just add in the ID as well as one of our arguments. So we'll have 2 arguments here. The event ID and the user ID. And I could flip these around. I'll leave them as is. We just need to make sure that we have the same, corresponding order as our parameters. So, boom. Now we can safely access just the individual, item for a specific user. And we do leave that generic in place here because that is going to be returning an array of events, even though we are really selecting just one event. Your database is still going to return an array of that event. So for our create function here, what we're going to do here is we're going to type the incoming data as an event object, and I'll just destructure out the requisite properties individually. So user ID, name, location, description, and then date time. Okay. Insert into events. And what we'll do here is similar to what we did for the queries in the users table. We'll just copy paste the columns here. Keeps it easy for us. And then we'll put our placeholders here. So we have 1, 2, 3, 4, 5 parameters. 1, 2, 3, 4, 5. And then finally, the nice part about keeping everything kind of in the same order is just like how we have our arguments destructured out and we have them placed in this order, we have our variables listed in our array here in that order. Now, for calendar events, if we are going to set up like a distinct page, to like navigate to after creating a calendar event, which like thinking of how Google Calendar operates, like I said, for this query, if we end up using this functionality, we'll use it. If we don't, we won't. But what I'm going to tell this create clause is that it is going to be returning at least the ID column. So I know that this is a create function, and with us not having provided a generic to the query function itself, it's going to give itself the default value of query result. Well, query result is going to actually take, it will have a rows property, and ordinarily it would be like empty, but we did specify returning here. So for this insert clause, it's actually going to give us back the data that we just created, or at least the ID column. So this metadata that we get back from the create function is actually going to have a dot rows property, and the element at index position 0 in that row is going to have the ID property of the ID we just created. So we might use it, we might not. But like I said, if we don't, we don't. If we, have it, no sweat off our back. So and we're just getting our exports set up. Now for our update, really just about every column we create an event with, I want to be updatable. So we'll take the same arguments including user ID. We are not going to update user ID. We do not want that to be in the query at all. But we will need it for our where clause. And we will also need the ID of the event that we're, updating. So we'll go ahead and we'll take the same arguments here, and we will also add in ID. And I can't remember if with the update and set syntax, if Postgres requires comments or not. I guess we'll figure it out if it breaks or not. So all right. So we've got the updatable columns that will pass this data down, and then we'll have the ID and the user ID for the where clause, which is going to be the same as this, just with our different numerical placeholders. So we'll bring that over here, add that in here. It's going to be our 5th and 6th placeholder respectively. Given that I've got these kind of in 1, 2, 3, 4, 5, 6 placeholder order, I'm going to rearrange our destructured arguments just to match that, just because I'm weird and I kind of like that continuity. So what I'm going to do is just flip these around, and because of that, this is going to be the same order that we put all of these in our values array. So All right. My formatter's rules being kind of weird. I don't exactly love how each one of these parameters gets their own individual line, but as long as it's applying these, rules consistently, I guess that's all right. So we'll make that updatable like that. And then finally, the destroy function. Pass in the ID and then the user ID. I'm trying to see which order I put. Okay, just being consistent, I did put ID first and then user ID, so I'll follow suit with that. And because, I've already got that, typed up here, I'll go ahead and just pull that down. And here, delete from events where, and then our where clause here in our deletion is going to be the exact same as our get one. So we can actually just overwrite all of this with that, except I had mismatched quotations, and now they are not mismatched. Okay, so we've got that. And all of our events queries, I think, are done for now. We have just kind of all of our general CRUD routes, so we'll leave it at that. We might find a use case for another. For our user accounts, we have our create and find. We could make a delete function or an update function for our user accounts if we decide to make like a profile page or something with like the ability to update settings. Let's see. Now that I say that, I'm gonna later add like an MFA preference. Preference, P-R-E-F-E-R, prefer, N-C-N-C-E. And I'll have that be like one of three strings, none, or email, or phone. And I'll set it up in the database later to be, a default value of none, but if they verify, email and phone, we'll allow them to set that setting. So that might actually be, let's go ahead and write a query for that. All right, update MFA. We're going to have a setting property here whose type is going to be of the user interface's MFA preference. Then the user ID property is going to be derived from the user interface ID property. And our query here is going to be update users set MFA preference. And let me just copy paste this just to make sure, I'm writing a query matching the exact property name. Like I said, I'm going to update the database later and add that column in, but update users set MFA preference equal to the first placeholder where and this is the user table, so the column name is ID, so let me rename that here to ID. And that setting variable, I might rename that to preference. Okay. Now I think we've got, let's see, let me rename my type just for convention's sake. I'll have that be a capital C. just to distinguish it from just regular variables. Okay, but I think I'm happy with our database queries. So let me go ahead and create an index here in our database folder to kind of daisy chain our imports and exports of our individual query files, just as a nice little convenience. So import users from queries users, excellent, import events from queries events, and then here we'll just chain out and export default of both of those default imports. All right, so our database work is tentatively done for now. Like I said, we might come back here and do some alterations, but that is a pretty big majority, I think, of what we would like to do. All right, so setting up auth. I'm going to go ahead and install bcrypt. And also JSON Web Token. You are free to use whatever sort of authentication, middleware you like. If you want to use some library like Passport, you are free to do so. But given that I'm going to be using just, local login mechanisms, aka email/username and a password plus JWTs, I generally find it faster and a little easier to work with just doing auth by hand, utilizing JWTs or JSON Web Token and bcrypt and just writing my own kind of custom middlewares. So that's what we're going to do here. While those are installing, I'm going to create a utils folder or utilities, whatever you want to call it. Let's see, I'll call this tokens.ts and I'll call this, passwords.ts. And I don't know if y'all remember from the previous video, but I've got that, foam shroud over my microphone arm. So it's pretty, reasonably sized. It's like a giant, square egg, crate style, foam thing that I don't remember what I purchased. I think like a spare motherboard for my brother or something. But yeah, it takes up, a lot of space, including like a sizable part of my monitor. So got to keep craning my neck over to see the left column. Anything beyond this kind of gets truncated. Let's see. So in this passwords file, we're going to import bcrypt. And all we're going to do is create some wrappers around like bcrypt's hashing functions and comparison functions. And with the tokens file, we're basically going to be doing the same with the JSON Web Token libraries, sign function, and also verify function. And the reason why I'm doing that is because we can create a single source of truth for signing tokens with that file in the event I decide to allow somebody to be automatically logged in upon registration in addition to just a regular login. So if there are like two spots I can sign tokens, it's pretty easy to forget to include a property. But if I define a function that can only accept something of the type of like an interface I define for what my payload should be, then I can only put that exact same info in if I reuse that. So yet again, just kind of hammering in that single source of truth methodology with this project. Really want to have some, good clean code. So is it a little more work? Yes, but do I get a great single source of truth? Yes. So we create a sign function here that's going to take the plain text password, which is going to be string, and it's going to return bcrypt.hash. And this is going to return a promise. So, just keeping everything nice and async whenever we can. And the hash function from bcrypt takes the plaintext password and we can create a salt of our own. But with the hash function, if you give it a number, it's going to generate a salt of its own. That number is going to be the amount of salt and hashing rounds, which, if you created that salt yourself manually, it would be doing the exact same thing. So I typically never generate my own salt manually. I just let the hash function do that for me, just because it's a little less code to write. But we'll pass in a plain text password here, and we'll go with what's kind of the current industry standard, 2 to the 12th amount rounds. All right, so that's our assign function, and then I'm really never satisfied with like the name of the function I choose here. So with this, we're going to be using the bcrypt compare function, and we pass in the plain text password, and then we pass in the hashed password from the database. And this function is going to return a promise that resolves with a Boolean as to whether or not the passwords match. So I'll call it that. All right. So we've got sign and passwords match. Boom. All right. Our tokens file here, which I guess I was already open. I could have just clicked on the tab bar, but whatever. Let's see. So for this, I want to go ahead and define like my token payload structure. So let's go ahead and do just that. Let's see. I'll put in the user ID, maybe the email and username and name. Yeah. Any name. I'll do all of these. If I want to remove some later, I can remove some. None of this is really like sensitive info per se. Maybe not email. I don't know. Maybe email. So like this app, every page is going to be private to an individual user. So like, I don't know. We'll let it be like this. And of course, I'm all about that single source of truth methodology. So instead of these properties here, it's going to be from the user interface. And then I just use the control D, to highlight each one of these, copy them over, wrote user, bracketed, put a string, in those brackets and just pasted those property names for a little speed shortcut. But that is going to be what I'm going to sign in every token. So all right. So I need to make another couple environment variables. I need to, there's my .env, create a signature. Or sorry, not signature, but a signing key. So here, locally, we'll go with the classic hunter2, and then I'll do something like 5 minutes here. just something super short for local testing. That's something I'm always recommend just to make sure that you've got everything squared away. So with your middlewares. So I will do, yeah, okay. I'll need to go to my configuration directory, and then, like I like to say, trust nobody, especially yourself. I trust myself least with environment variable names, so and your expiration is not anything actually secret. We are using environment variables here to manage different values for different environments for their like actual intended purpose. Hiding credentials and secrets is kind of their secondary purpose, but switching values between environments, their like actual primary purpose, is exactly what we're doing here. So production, definitely going to make it longer. Here locally, we are making this, well, short. So all right, let's go ahead and import our config index. We need to pass in, well, our secret or private key, which we have under config jwt secret. We also need to make sure that in our options object here, we actually specify an expiration instead of having an infinitely lived token, which would be very, very bad. So yeah, if we don't provide this value, it's infinite. So that is going to return our actual JWT. We give it the raw data, and it returns the true JWT. Now, the JSON Web Token library is not going to be happy if you try to give it undefined as a password, which is the possible value coming from an environment variable. So we do need to validate this. So what I'm going to do here is and let's see. Well, TypeScript should be context aware of that. It should be a string or undefined. This is validating after this that it is not, falsy. If it's only two possible values are string or undefined, the falsy check would get hit if it's undefined. So therefore, beyond this, that should only be truthy. Let's see, let me close out of this file and reopen it. Interesting. So here in this example, they've got this as secret or private key null typed. TypeScript should be aware of that. We do have that being handled here. Let me just move that in the function here. So, okay. All right, so here we've got that thrown error in the scope of this function. So it's now aware that it can only be defined as a string here. And now we can go ahead and replace our expiration. Okay. And then we can return this value. Cool. So that is our sign function, and then we can go ahead and do our verification function. So we'll receive the token itself as a string here, and just to make sure, let's see, no other token variables defined. Excellent. And I'll create a variable here called payload because we're going to be extracting all this information out from the token itself. So we'll say jwt.verify our token. We'll pass in our key here, so that way the JWT library can see if, well, it can recreate everything. And we'll go ahead and do our same validation that we did previously. All right, and in the event that it can't verify for any reason whatsoever, it's going to throw an error. So, whenever we're using verify, it's going to be in a try catch block. So that context is going to catch whatever is going to be the issue, whether it's, an expire token, potential cause, if it's just a bad signature, if somebody's trying to like spoof the token, if it is, let's see, just a bad format. Let's say it, a character was truncated or something. It's not truly a JWT at that point. Any of those would cause an error to get thrown. So whatever the calling context of this verify function is, should catch that. But otherwise, if everything is good, all the info in there gets extracted out as payload. And then this is going to be the value we return. And what I can do here, just for some sick intelligence, is cast this as our payload type. And so that way, here, whenever we are calling the verify function somewhere else, we can go ahead and, extract our token info out, directly set it to our request user, and then boom, we got some great intelligence. And then this should just say string. Yep, cool. So that's really all we need in this file. But the beauty of this is that these two functions have a single source of truth of what can come in and what comes out. And so that way, if I do have multiple files running this verification function, instead of it just being this, jwt.verify on its own, we have this single source of truth function, which says, look, if everything goes well, you are always going to get this data back. And for the signature, the signing function, if we were to create a token in multiple spots, like on a login attempt or a registration attempt, well, this says this is the only data that you can send in. So it prevents some silly issue like if you register and you add in somebody's username and email, but you forget to like add their freshly created ID. But if you do that on, login, you have two differing types of tokens. Plenty of headache that could cause at some later point. I had a student do that a couple years ago, and I remember that was like an entire day he spent debugging it, and that was a big headache for him trying to figure out why that happened. And when he discovered it, he was like, no way. So, single sources of truth might be silly, creating a file just to have, two functions to wrap around a line or two of code, but stuff like this is really handy because it takes a couple of minutes to write, and could potentially save you or somebody else hours of debugging for a silly little, tiny error. All right, and you know what? In our utils folder, just like everything else, I've been doing lots of kind of like default import, default export, daisy chaining with index files. I'm going to do the same with this utils folder. So we'll create an index in here where we will import all of our utility files, and it just gives us nice clean imports and exports. So import passwords, import tokens, all right. So we've got some good clean structure and some good, nice little helpers here. Let's go ahead and start defining some authentication middlewares. See, I might rename this folder to just like MW, MWS. I don't like VS Code not having the fancy little icons for my icon pack extension, so I'll go back to middlewares. All right, login. All right, we're going to import the request handler type from Express instead of the request, response, and next types or next function types. Request handler is just the type definition for a function with the request, response, and next function types. So I type one function instead of 3 properties. Just kind of a little convenience thing. And then the user, the database. Okay. That might be all we need for now. Yeah, we'll let that be. So let's go ahead and start defining our login middleware. So right now, rec res next, all completely untyped. So they've got the implicit any types, which with our ts config, we have no implicit any, which is a great rule because, I mean, you want to have stuff typed. Like you want your TypeScript help. So here, we just type this as a request handler function, and just like that, request is an express request, res is an express response, and next is an express next function. So gotta love that. So we're going to destructure the email and password out the rec body, and I'm going to let users log in with either the email or username. So I'm just going to have, coming from the client side, an email / username input. It's just going to be one singular input. I'll have like a label saying they can log in utilizing either, but I'm just going to send down, one value. So let's see. We're going to look for a Stack Overflow regular expression to determine if something is an email or not. So Stack Overflow. Oh, I think, let's see. I've got just that question here in my browser history. So we're not going to get like an insanely crazy good one. We can do just like a smaller decently sized one that somebody says, matches some good specification. I did see a couple above that I think were pretty okay looking. And some people are like, oh, my programming language like C# or PHP, has a built-in validator. Good for you. We don't, but... And I know regular expressions, aren't perfect. Regular expressions can be... So this is one that adheres to the HTML5 spec, but it doesn't adhere to... like stricter specifications, and the HTML5 like willfully says to, violate that. Interesting. We're all learning a bunch today, aren't we? And there are a lot of different standards for like what an email, structure should be. Not what like an email regular expression should be, but like what an email structure should be. So, interesting. I'll go with something like this. That is good enough for me. So I'm going to create in a regular expression here. So with JavaScript, you define a regular expression with, 2 slashes, just like how, a lot of other languages would define a regular expression. And it's going to look like a string format. It's not a string. We don't delineate, the beginning and the end of this with quotation marks or backticks. It is between the slashes where we define the body of our regular expression, and then after the second slash, if we have any flags, we would add those there. So we could add something like global or like insensitive for this, but I'm pretty sure this regular expression would take care of that regardless. We don't need the global flag because we should only be getting like one email address, collectively. And we don't need insensitive because this is searching for both lowercase and uppercase letters. So that should be good. So what do we do with this? Well, if we do validate and make sure that we have an email and password, let's go ahead and validate that real quick. All right, we'll send up a JSON response. We'll send up a status code of 400 and return just to validate that we have both an email and password defined. And then here we've got a regular expression, and we know that email here is at least something truthy. So we could also validate that it is a string. This is a calendar app, so I'm not going to go like ridiculously crazy on my validation. If I were dealing with more sensitive data, I very much would want to make sure that I have the correct data type and then any other data specific, constraints. So if I'm accepting strings, I might want to make sure that the email coming in is no greater than like 128 characters. Password, not really going to care about the length because it gets, salted and hashed, so we should have a fixed output regardless of the, input size. But I'm not going to do that for this application in specific. So, but at least, now we know it's truthy. It's at least not undefined. And if it's a string, it is at least not an empty string. So we've got our email pattern here, and we can say, okay, well, I'll create a variable here called isEmail, and we're going to use a function built into JavaScript's string object, which is the string.match. And you can give a regular expression to that function. If that regular expression finds match or matches, plural, it will return an array of all of the, substring matches. And if there are no matches, it returns null, which is great because you don't necessarily have to care about the returned data. You just have to know if it's truthy or falsy. If you do actually get data back in that array, it means it matched your pattern, and therefore, it is an email if it's truthy. And otherwise, if you get null back, null is falsy, so is email would be a falsy value. So you can just use that in an if statement. So I can say is email is equal to email dot match. And I'm not going to get IntelliSense on that, so it doesn't know what the type of email is. So I should at least check this, I guess, to see if type of email does not equal string. There we go. So if I run this line of code, if I can proceed beyond that if statement in the early return, it does mean that email must be a string. Because, we were able to check and say, okay, well, we checked to see if the type of email was not a string, and we didn't hit that condition, so therefore it must be a string. So here we get all of these string, IntelliSense, including the .match function, which returns, like I was saying, these two different bits of data, either an array of all of the regular expression matches or null. So truthy, falsy. So we can use it as a Boolean if we do a double negation, or we can just do an if statement evaluating the truthiness. But we'll pass in that email pattern here, and is email is going to let us know if we should attempt to log in that user as their email or as their username. So now we're about to run some database operations. We do need to look that user up, so that way we can extract out their password. So since we're dealing with database operations here, we do need to go ahead and set up our try catch. And I'm not going to utilize a logging service. I'm just going to throw out a simple console log for this application, but we'll go ahead and log out any error, and I'll go ahead and give a general 500 status code. And we'll give a message of cannot log in at this time. Please try again later. Let's see, that's kind of like a cop-out message, because the issue at hand would be maybe like a database connection error, or potentially just a bad query or something. But we'll eventually be testing our queries, and if we do get this 500, we can kind of craft that a little bit better. But I mean, that should only really get hit for like a database connection issue or a bad query. So and I didn't make this function asynchronous, so let me go do just that. So we'll await db dot, we'll get our users queries, and we'll do find by, and we can utilize this is email here. We can evaluate its truthiness and do a ternary to see which column we should, log in as. So if, that rec.body.email passes that regular expression, is email would be truthy. So if is email is truthy, we'll use email. Else, we'll use username. And we'll always pass in rec.body.email as our actual value. It's just that, they might have their username in there instead of an email. So now this function find by does return a user array. It's just because our database, it can't know that we're querying something by a primary key ahead of time. So even though we know that we are hitting up something by a unique column, I said primary key. We're not actually looking up the user by the primary key. We are looking it up by a unique column, regardless, email and username are both unique. But even if we were looking up our user by ID, can't tell ahead of time. So it's always going to return that in an array. So we just array destructure our user out. And maybe somebody put garbage in. So what do? Well, I'm going to send up the same response for a couple of bad conditions in this try block, just because if somebody's trying to do like an online brute force attack, we probably will want to do something like rate limiting. But even with something like rate limiting in place, if somebody is brute forcing after finding a breach on like some other site with like plain text passwords and emails, I don't want them trying out combos. And if I say like, oh, well, your email is good, but the password you tried is bad, I just confirm to them that they've, searched through their list and found a valid email on my site. And then from that, they can just brute force like the, top 1,000, most common passwords. So I really don't want to give any indication whatsoever an email is valid. And unfortunately, a lot of sites these days will do a two-step login process where they will let you log in with an email first, and then they bring up a secondary modal or like add in a conditional, password panel only if the email matches. And if it doesn't, they will let you know that ahead of time. So, they are doing some security mitigation by doing rate limiting, but I still do not like that as a software developer. I really don't like, releasing any user information if I can avoid it. So because of that, I will send up a generic, 401 here saying like invalid credentials. So that doesn't give any indication as to whether or not it was, a bad email or password. That's a little bit worse on the user experience side, but I'd rather a small UX hit for a lot more security. Yet again, just a super nitpicky thing of mine, but all right. But once we do have that user object, we can go ahead and let's see. We've got our password utils. What I actually want to do here is just import the entire utils folder, and what we'll do with that is use utils.password and eventually utils.token. We do have some MFA logic to work out, the email verification workflow we need to work out, and we do need to integrate something like Mailgun. So that's probably going to be our next step. But for now, we'll assume everything's okay. We don't have to worry about account verification. We can at least kind of like mock out some of that pseudocode. But here, we'll go ahead and check to see if the passwords match. So here, there we have the plain text password via rec.body. Password. That's what they're passing in. And then we have the hash password, what's stored on the database in that user object. We've verified that user object, is truthy, because we, just validated that on line 17. So here, this function returns a Boolean, so we have passwords match. Oh, and let's see. I forgot that bcrypt, I was using their async function, so we'll await, and that gives us back a Boolean. And here we'll check to see if not passwords match. And what we're going to do for that is just kind of what we did for a bad, email or username. So now if somebody gets this and they're trying like an online brute force attack before rate limiting kicks in, they won't know, judging by this response, if they had a bad email/username or they had a good one but a bad password. So just kind of a weird nitpicky thing of mine. All right, once we've got that, we know this user's legit, and we'll go ahead and simulate some of the login workflow. So ordinarily here, I would go ahead and create and grant a token. We're going to, for this app, I don't want users to be able to log in until they've verified the account. So I'm just going to block all login, attempts until verification, is good. So what we'll do here is say if not user dot email verified. Return res.status 403. And so we're setting up a 403 because we have, authenticated who they are. We know who they are, but 403, they are not authorized to access this resource. So we know the user, but they got to validate their account first. So you must verify your email first. So here we'll just give them a message saying they need to recheck, their email. So what we'll do is upon a login attempt, if they're unverified, resend the email with a new code and invalidate previous codes. As far as invalidating previous codes, I might create like a codes table in the database where we can, put codes and we can delete all for that user whenever we need to regenerate. So we could have some stateful codes. We could also use something like Redis to have an in-memory database. And that way we don't have to store it like on our actual, relational database, because that's really more or less non-relational data. Well, no, because we would at least want it to have a foreign key to the users table. So yeah, it would be relational. Or we could keep it completely stateless. They would just have, we could send like JWTs instead of like UUIDs. So maybe invalidate previous codes, maybe not, but at the very least, for every login attempt they do, if they're not verified, we want to resend the email. And so that way, if they don't check their email for like a half hour, they try to log back in again, they get a new code. And that way, well, they have the ability to, verify their account. Otherwise, if they are verified, we can go ahead and grant them their token. So const token is equal to utils.tokens.sign. This requires something matching the payload object structure. So that has an ID, which is going to be derived from the user table. And we can go ahead and just destructure these properties out for convenience's sake. So we have that user object we retrieved from the database above. I can extract out ID, email, username, name. And those are the 4 properties we were going to pass in to create the token. So we'll just do that for convenience's sake here. And the nice part about this is if I do this logic for registration, well, in this app's example, I'm actually not, because like I said, for registration, I'm not going to be automatically logging them in because I'm not permitting users to do anything until their account's verified. And why am I being a stickler about that? Well, if we enforce email verification, that's better for security for your apps, long term. But it also lets you do, some cool features that, do have some security implications. You can do like magic link logins to where like somebody just types in their email and then they click a link and they get logged in automatically. They don't have to type in their password. You can do password resets. You can do multi-factor auth via like emailing a code to them. So, you know, it does unlock some good possibilities, but all right. So if they are verified and everything else lines up, here we go ahead and grant them their token. So that is our login middleware. And then we'll go ahead and define a token verification, just making sure that JWT is good if they are a valid logged in user. So const, let's see, call that token check. And this function is also going to be an express request handler. Surprise, surprise. Might not need to be async because we'll be dealing with the JSON web token library, which I think is only synchronous, and I didn't wrap it with like a promise, so I think it doesn't have to be async, but we'll see. So here, like I said, this we're going to be dealing with everything kind of by hand. So we are going to be extracting out our info from the rec itself. So I need to grab the auth headers from the rec.headers.auth and then validate everything. So if not auth headers, return res.status 401.json message missing auth headers. All right, beyond that, we're going to be sending, you know, we're dealing with just JWTs. We're keeping it kind of simpler on this application itself. We can go ahead and array destructure out the splitting of that auth header. So, you know, we're going to be sending in everything as like bearer, you know, EY, blah, blah, blah. So if this is our auth header, split on an empty space, gives us an array of bearer, and then our actual token. So see, and I'm not using token as a variable anywhere yet, which is pretty rad, so we don't have any naming conflicts with that. If not type, or not token, or type does not, type dot to lowercase does not equal bearer. Yeah, and for this, I'll just say like invalid auth header. We'll go with that. All right, but once we actually do have this, we can go ahead and attempt to verify the token itself. So we'll go ahead and do our quick and dirty error handling here. And because anything can be thrown, there isn't really a defined like type for a caught error. So if you do want to have some TypeScript, you know, support on that, what you can do is say like const new variable is equal to your error, whatever you catch, rather, as an error construct. And that's really annoying, but because we can throw anything in JavaScript, it's kind of how we have to deal with that. So, and whatever gets thrown, that .message property from the JSON Web Token library is gonna be like the context saying like expired token, invalid token, structure, bad signature, etc. Let's see. Yeah, we'll go with payload. So we pass in the token into our verify function, and it's going to extract everything out or throw an error. We've got the error throwing, handled appropriately. And so here we have our payload. What are we going to do with this? Well, this is going to be what we inject into the rec user. So we're going to have token check in front of any routes that we need to make sure we have a legitimately logged in user as so. Payload is going to be, that ID, name, email, username, and all of that can go into this. Now we're about to make TypeScript a little bit mad, but that's not too bad. We'll get this fixed up. So we inject this into the rec via a brand new user property, setting it equal to, our payload structure, and we call the next function. So this is going to be applied in front of a route. And then that means the route sitting behind it can, reference rec.user.id, rec.user.name, rec.user.email, etc. But TypeScript doesn't know that, user exists on the rec object. So we do need to go ahead and type that. And we can just create a global type here. Under the express namespace. And what we're going to do is just redeclare the request interface. So when you deal with exporting interfaces, it's kind of an additive effect. I don't overwrite the express request, I just add on properties to it. So if I wanted to, I could make like a rec.farts, property whose type is going to be of our payload. And so here I could actually say like rec.farts is equal to payload, and it satisfies that. Now that's kind of a goofy example. That probably would be one I would use in class day to day, with my, Catalyst students. But for code that's going to be public, I think user is probably a more appropriate term than farts. So here, whenever I am dealing with an express request object, this is implicitly, typed automatically everywhere. I use the express request object. So if I did have some routes, actually here in the login request, if the login request sat behind token check, technically, we'd have access to rec.user. All of these properties. Now, that wouldn't be like the proper correct workflow, but any other route sitting behind token check would legitimately have access to that. So we inject that data into a new property, user, on the express request, and then we call the next function so it has access to that. And now we'll go ahead and we'll set up our middlewares to be exported. Well, this was intended just to be like my login middleware, but I also have my token check one in here. I might just make this my index file and then just do a default export, from within here as is. Let's do that. So here we'll create index.ts. There we go. Yeah. And maybe if I do add some additional middleware, some other, login mechanisms, then I might consider splitting this up into multiple files, but I think for the time being, I'm pretty happy with that. Let's see. I do see some TypeScript errors in my server folder. Is that just for my tsconfig? Yeah, okay, just one problem with the tsconfig. Okay, yeah, everything's good. So, let's see what's going on with this. I don't think I made a commit after the first video. Oh well, I'll just have a really large commit for both the first video previously and then this. I might try to separate the files to have a couple distinct commits between the two. But yeah, so that's about it for this. I think in the next video, I'll be creating some controllers and then potentially setting up some routes. And if we do that, that means I can actually fire up Postman and we can start getting some API testing going on, which would be pretty rad. But anyway, I know this was a long one because there's a lot to cover when auth is involved, but if you're enjoying this so far, go ahead, like this video, subscribe, and that way you can see when the next video in the series comes out. Until then, I'll see you later.